Hello everyone, welcome back. Today we will be starting a new chapter. Just to recap what we have been doing so far. We started by looking at a particle that has essentially no dimension. We analyzed its motion and we analyzed the relationship between forces and motion of particles. We also looked at a general condition or system comprised of many particles. We had system of particles, and we saw how we can solve many things about a system of particle with surprisingly high level of generalizability. We could solve a lot of real practical problems. But the issue, well, not the issue, but the point was we were studying a single particle or a system of particles moving around relative to each other. In reality, we really don't have a particle. Everything has some finite measurable dimension. And because of that, we also need to worry about not just the movement of like translational movement of these bodies, because they have dimensions. They can also rotate, and we need to study the rotation as well when we are talking about the movements. So that is what we are going to look at next. We are going to study movements of bodies with finite dimensions, and that is, as you will see, and I already mentioned, is heavily influenced. Everything we do is heavily influenced by rotation of these rigid bodies. So, first things first. One other thing before I move forward, we will be looking at 2D movements, planar movement. 3D movements, especially 3D rotations, are quite complex on their own, and studying them actually requires a whole lot of new mathematical tools that we don't have yet in this course. So we restrict ourselves to bodies that are moving on a two-dimensional space. So just as a background, heads up to know what you're expecting. Okay, now let's get to it. The title is Planar Motion of Rigid Bodies. A few things for sake of concreteness we need to define first. First thing, what is a rigid body? A rigid body essentially is a system of particles, a system of particles, a group of things, but the things must have a particular conditions. A system of particles that do not move relative to each other. So if you have a bunch of stuff and all of them are fixed, fully fixed, relative to each other, we can consider those as a rigid body. Obviously, you can argue that any physical object we're dealing with is really not rigid. Everything, even a steel piece of a heavy steel, everything deforms and nothing really stays fully fixed in its shape. But for all practical reasons, many of the objects we study under normal loads deflect so little, and the distances between its particles change so little, that we can safely assume that body behaves like a theoretical rigid body. But note that this rigid body, the way we have defined it, is a is kind of theoretical, doesn't really exist in reality. The next thing that exists in the title is planar motion. So let's define that too. Planar motion. Planar motion is a kind of motion, for a body, for a rigid body. Let's make it more concrete. For a rigid body, where doesn't have to be rigid, but let's call it rigid, where all points, all particles, all points on the body move on planes that are, it's going to be a very long sentence, that are a fixed distance from a given plane. So you can have one plane, an arbitrarily shaped object. Any point on this body moves on a plane that is parallel and fixed distance to that reference plane. You don't need to have the reference plane, just as long as all points move on planes parallel to each other, that's fine. So you see what planar motion means. It is not that your body has only 2 dimensions. Your body can be 3-dimensional, but all the points move in 2D spaces. Okay, now that we have these definitions, next I want to define 3 kinds of motion that we will study individually. When we are talking about planar motions of rigid body, we can have 3 types of movements. First one is a pure translational motion. And a pure translational motion, you can have a randomly shaped body, and as you take any 2 point and make a line, first of all, because it's a rigid body, that line always remains a fixed distance and a fixed angle relative to the body. And when you have translation, as the body moves around, I'm trying to make it as similar as I had before. This line always remains parallel. Why did I draw it like that? Remains always parallel. The body doesn't need to go along a straight line. It could go along a curvature, but any line you pick on the body should always remain parallel to its original self. That's translational. The next one is a pure rotation, or rotation about a fixed axis. And again, you can have a randomly shaped body, an axis, and it is defined when any point you pick on the body moves on parallel circles that all of them have their centers along the axis of rotation. And finally, if it's not translation or rotation, it's a general motion. General planar motion, essentially a motion that is neither pure translation or pure rotation. So you have your body, and it may undergo a different. So this line becomes that line, and this point goes there. That point may go there. Ugh, it's really not going to work, but that's fine. Like this. Anyway, the lines turn, and also there is no way you can find an axis that the body is rotating about that. So these are the three kinds of planar motion. All three of them are planar. They fit this kind of description. And we will study them one by one. We start with translational. That is the easiest. We will see it is practically nothing new. Then we move on to rotation about fixed axis, and finally general planar motion. And that is what we will do in this chapter. So in the next video, let's start with analyzing the kinematics of planar motion during pure translation. So until then.